Wire nuts are indeed considered when calculating box fill in non-metallic electrical boxes. Box fill calculations are a fundamental aspect of electrical installations, ensuring safety and compliance with the National Electrical Code, or NEC. The NEC specifies the maximum number of conductors, devices, and fittings allowed in an electrical box to prevent overheating and potential fire hazards. When determining box fill, several factors must be taken into account. Firstly, the volume of the box itself is a critical parameter. This volume, typically expressed in cubic inches, dictates the overall capacity of the box. Secondly, the number and size of conductors entering the box are key considerations. Each conductor, depending on its gauge, contributes to the total box fill requirement. For instance, a 14 American wire gauge, or AUG, conductor requires less space than a 12 AWG conductor. Thirdly, any devices or equipment installed within the box, such as switches, receptacles, or equipment grounding conductors, also contribute to the box fill calculation. Each device is assigned a specific volume allowance based on its size and type. Finally, and most importantly in this case, wire connectors, including wire nuts, are included in the box fill calculation. The NEC addresses box fill requirements in Article 314.16. This article provides detailed guidelines on how to calculate the maximum number of conductors and devices permitted in a box. Specifically, Section 314.16. B outlines the rules for conductor fill, while Section 314.16. C covers equipment grounding conductor fill. Section 314.16. E addresses the volume allowance for devices and equipment. Now let's delve into the specifics of how wire nuts are treated in box fill calculations. Wire nuts are used to connect two or more conductors together inside an electrical box. They come in various sizes to accommodate different numbers and gauges of wires. While the wire nut itself doesn't have a specific volume listed in the NEC, the conductors connected by the wire nut do. When calculating box fill, each conductor that passes through the box or terminates in the box must be counted. This includes the conductors connected by the wire nut. To accurately account for wire nuts in the box fill calculation, consider the following steps. 1. Determine the total number of conductors entering the box. Count all wires, including those connected by wire nuts. 2. Determine the size or gauge of each conductor. The gauge of the wire determines its volume allowance in the box. 3. Refer to NEC Table 314.16. B1. To find the volume allowance for each conductor based on its gauge. This table provides the cubic inch volume that each conductor occupies in the box. For example, a 14 AWG conductor might have a volume allowance of 2.0 cubic inches, while a 12 AWG conductor might have a volume allowance of 2.25 cubic inches. 4. Add up the volume allowances for all conductors in the box. This gives you the total conductor fill requirement. 5. Add the volume allowances for any devices or equipment installed in the box. This includes switches, receptacles, and equipment grounding conductors. 6. Compare the total box fill requirement to the volume of the box. The total box fill requirement must not exceed the volume of the box. If it does, you will need to use a larger box or reduce the number of conductors or devices in the box. Here is an example to illustrate the process. Suppose you have a non-metallic box with a volume of 20 cubic inches. Inside the box, you have 6 12 AWG conductors connected by wire nuts, 1 single pole switch, and 2 equipment grounding conductors. To calculate the box fill, firstly determine the volume allowance for each conductor. According to NEC Table 314.16, B1, a 12 AWG conductor has a volume allowance of 2.25 cubic inches. Secondly, calculate the total conductor fill requirement. Since you have 6 12 AWG conductors, the total conductor fill requirement is 6 multiplied by 2.25, which equals 13.5 cubic inches. Thirdly, determine the volume allowance for the single pole switch. According to NEC 314.16, A single pole switch has a volume allowance equal to twice the volume allowance of the largest conductor connected to it. In this case, the largest conductor is 12 AWG, which has a volume allowance of 2.25 cubic inches. Therefore, the switch has a volume allowance of 2 multiplied by 2.25, which equals 4.5 cubic inches. Fourthly, determine the volume allowance for the equipment grounding conductors. According to NEC 314.16 B5, all equipment grounding conductors in a box are counted as a single conductor based on the largest equipment grounding conductor present. Let's assume the equipment grounding conductors are 14 AWG. According to NEC table 314.16 B1, a 14 AWG conductor has a volume allowance of 2.0 cubic inches. Therefore, the equipment grounding conductors have a combined volume allowance of 2.0 cubic inches. Fifthly, calculate the total box fill requirement. The total box fill requirement is the sum of the conductor fill requirement, the switch volume allowance, and the equipment grounding conductor volume allowance. In this case, the total box fill requirement is 13.5 plus 4.5 plus 2.0, which equals 20 cubic inches. Sixthly, compare the total box fill requirement to the volume of the box. The total box fill requirement of 20 cubic inches is equal to the volume of the box, which is also 20 cubic inches. In this example, the box is filled to its maximum capacity. If you were to add any additional conductors or devices to the box, you would exceed the box fill limit and need to use a larger box. It's important to note that the NEC provides specific requirements for box fill calculations, and these requirements can vary depending on the type of box, the type of conductors, and the type of devices being installed. Therefore, it's essential to consult the NEC and any applicable local codes to ensure that your electrical installations are safe and compliant. In addition to the basic box fill calculations outlined above, there are a few other considerations to keep in mind. Firstly, if the conductors entering the box are of different gauges, you must use the volume allowance for the largest conductor when calculating the box fill. Secondly, if the box contains any internal cable clamps, each clamp must be counted as one conductor based on the largest conductor that enters the box through the clamp. Thirdly, if the box contains any fixture studs or hickeys, each stud or hickey must be counted as one conductor based on the largest conductor attached to it. Fourthly, when using non-metallic boxes, it's important to ensure that the box is properly supported and secured. The NEC provides specific requirements for supporting non-metallic boxes, and these requirements must be followed to prevent the box from becoming dislodged or damaged. Fifthly, when using non-metallic boxes in damp or wet locations, it's important to use boxes and fittings that are listed for use in those locations. These boxes and fittings are designed to prevent moisture from entering the box and causing corrosion or electrical hazards. In summary, wire nuts are included in box fill calculations. Accurate box fill calculations are essential for safe and compliant electrical installations. By following the guidelines outlined in the NEC and any applicable local codes, you can ensure that your electrical boxes are properly filled and that your electrical systems are safe and reliable. Understanding box fill is not just about meeting code requirements, it's about ensuring the safety of people and property. Overfilled electrical boxes can lead to overheating, insulation breakdown, and ultimately, electrical fires. These fires can cause significant damage and even result in injuries or fatalities. Therefore, it's crucial to take box fill calculations seriously and to always err on the side of caution. If you're ever unsure about how to calculate box fill or whether a particular installation meets code requirements, it's always best to consult with a qualified electrician. They have the knowledge and experience to ensure that your electrical systems are safe, compliant, and reliable. Furthermore, remember that the NEC is not a static document. It's updated every 3 years to reflect changes in technology and best practices. Therefore, it's important to stay up to date on the latest NEC requirements and to consult the most recent edition of the code when designing and installing electrical systems. Also, consider that local jurisdictions may have amendments or additions to the NEC. These local codes can be more stringent than the NEC requirements, so it's important to be aware of and comply with any local codes that apply to your area. In addition to the NEC, there are other resources available to help you understand box fill calculations and electrical safety. These resources include textbooks, training courses, and online tutorials. By taking advantage of these resources, you can expand your knowledge of electrical safety and improve your ability to design and install safe and compliant electrical systems. Ultimately, electrical safety is everyone's responsibility. By understanding box fill calculations, following code requirements, and staying up to date on the latest electrical safety practices, you can help prevent electrical fires and protect people and property from harm. One other point is the proper installation of wire connectors, or wire nuts themselves. It's crucial to select the appropriate size and type of wire connector for the number and gauge of conductors being joined. Using the wrong size or type of connector can result in loose connections, which can lead to arcing, overheating, and potential fire hazards. When installing wire connectors, always follow the manufacturer's instructions carefully. Strip the conductors to the proper length, twist them together tightly, and then screw on the wire connector until it is snug. Be careful not to over-tighten the connector, as this can damage the wires or the connector itself. After installing the wire connector, give each wire a gentle tug to ensure that it is securely connected. If any wires come loose, re-strip the wires and reinstall the connector. Also, when working with non-metallic boxes, be sure to use non-metallic wire connectors. These connectors are designed to prevent damage to the conductors and to maintain the integrity of the non-metallic box. Finally, remember that electrical work can be dangerous. If you're not comfortable working with electricity, it's always best to hire a qualified electrician to do the work for you. They have the training, experience, and tools to perform electrical work safely and correctly.